DSPy's BestOfN module implements a stochastic optimization strategy for language model outputs, leveraging multiple sampling attempts to select predictions that maximize a custom reward function. This approach combines the flexibility of declarative programming with the robustness of ensemble methods, allowing precise control over output quality through user-defined metrics. We're about to examine how this mechanism is configured for a summarization task, where the reward function incentivizes outputs approaching an ideal word count. The implementation will demonstrate the module's initialization with a chain-of-thought predictor, the definition of a length-based scoring heuristic, and the execution parameters that govern the sampling process.
Import DSPy. Def ideal length reward args pred. DSPy. Prediction float. Reward the summary for being close to 75 words, with a tapering off for longer summaries. Word count equals lenpred. Summary split. Distance equals absorbed count 75. Return max 00. One distance slash 125. Optimize summarizer equals DSPy. BestOfN. Module equals DSPy. ChainOfThought text summary. N equals 50. Reward FN equals ideal length reward. Threshold equals 0, 9. Result equals optimized summarizer. Text equals long text to summarize. Print result summary.
This code demonstrates how to use DSPy's BestOfN module to optimize a summarization task with a custom reward function. The pattern leverages multiple LM calls to find the best summary based on a specific quality metric. In this case, a target length of 75 words. The ideal length reward function implements a scoring mechanism that rewards summaries closer to 75 words, with a linear penalty for deviations up to 125 words. This reward function is then used by BestOfN to evaluate 50 different summaries generated by a ChainOfThought module. The module stops early if any summary meets the 0.9 threshold, otherwise returning the highest scoring result. This approach is particularly useful when you need to enforce specific output constraints that are difficult to express in prompts alone. By generating multiple candidates and selecting the best one, you increase the likelihood of getting a high-quality result that meets your criteria. However, this comes at the cost of increased computational resources, as it requires multiple LM calls. The threshold parameter helps balance quality and efficiency by allowing early termination when a sufficiently good result is found. Let's break it down.
Import DSPy.
Imports the DSPy framework for building language model programs with modular prompting techniques.
Def ideal length reward args pred. DSPy. Prediction float.
Defines a function named ideal length reward that takes args and a pred parameter of type DSPy, prediction, returning a float value. The function appears to be a reward calculation for evaluating prediction quality based on length criteria, though the implementation details aren't visible in this segment.
Reward the summary for being close to 75 words, with a tapering off for longer summaries.
Imports the Bootstrap Fewshot with Random Search optimizer from DSPy's teleprompt module, enabling automatic few-shot learning with random search over generated demonstrations to optimize DSPy programs.
Word count equals lenpred. Summary split.
Calculates the word count of a summary by splitting the pred summary string into words and counting the resulting elements. The variable word count stores this integer value representing the number of words in the summary.
Distance equals absorbed count 75.
Calculates the absolute difference between word count and 75, storing the result in the variable distance. This measures how far the word count deviates from the target value of 75, regardless of direction.
Return max 0, 0. 1 distance / 125.
Returns the maximum between 0 and the value of 1 minus the ratio of distance to 125, effectively computing a normalized score that decreases linearly from 1 to 0 as distance increases from 0 to 125 and remains 0 for any distance greater than 125. This implements a simple linear decay function with a cutoff at 125.
Optimized summarizer equals DSPy, BestOfN. Module equals DSPy, ChainOfThought text summary.
Creates a BestOfN optimizer instance that wraps a ChainOfThought module configured to transform text inputs into summary outputs. The BestOfN module will execute the ChainOfThought module multiple times and select the best result based on a reward function.
N equals 50.
Sets the variable n to the integer value 50, likely configuring the number of attempts or samples for a DSPy optimization process.
Reward FN equals ideal length reward.
Assigns deal length reward as the reward function for evaluating predictions, which will be used to score and select outputs based on their adherence to an ideal length criterion.
Threshold equals 0, 9.
Sets a threshold value of 0.9, which will be used as a minimum score or confidence level for filtering or validating predictions in DSPy modules like BestOfN.
Result equals optimized summarizer.
Calls the optimized summarizer function and assigns its return value to the variable result. The function appears to be a DSPy module that has been optimized, likely for text summarization tasks, though the specific implementation details and parameters aren't visible in this segment. The result variable will store the output prediction or process data from this summarization operation.
Text equals long text to summarize.
Assigns a string variable named text containing the literal value long text to summarize. This creates a simple text container that will likely serve as input for subsequent text processing operations, though the exact usage isn't visible in this segment.
Print result summary.
Prints the summary attribute of the result object, displaying its contents to the console. The BestOfN module in DSPy implements a stochastic optimization strategy that combines declarative programming with ensemble methods to refine language model outputs. Here, it's configured with a ChainOfThought predictor for summarization, where the goal is to generate outputs close to 75 words. The ideal length reward function defines this constraint, scoring summaries based on their proximity to the target length with a linear penalty for deviations. By setting n equals 50, the module samples 50 summaries, evaluating each against the reward function. The threshold equals 0. 9 parameter allows early termination if a sufficiently high-scoring summary is found, balancing computational efficiency with output quality. This approach is particularly effective when precise output constraints are needed, though it trades off increased computational cost for higher reliability. The key insight is how the reward function and sampling parameters work together to enforce specific quality metrics that are difficult to achieve through prompting alone.
BestOfN chases the perfect 75 words like a dog chasing its tail, while ChainOfThought dances in the wind of infinite thought.